Yes, all right. You guys are familiar with inverse operations, but what we have here is we have our normal distribution, and the normal CDF function takes a range of values, a mean and a standard deviation, and returns the probability, or remember, probability is the same as area underneath that curve. And we were finding probabilities. Now what we're going to do is we're going to find what are called k-values, all right, or quantiles. It's just a fancy term for now we're figuring out what the scores had to be. And we're going to know what the area below that curve is, or we're going to know what the probability is. Now, one thing that will be really helpful, and actually this is one thing that has shown up on a number of the IB exams, is being able to sketch the curve to represent a given situation. Okay? So, let me just take a look at an example. We'll sketch it. We'll look at a couple examples, then a couple variations. All right? Here we go. So here we have a case where we have the random variable x that's distributed normally with 7. What does 7 represent? The mean. A mean of 7. And what's 2.25 represent? Variance. Okay, be careful with that. And often, remember, they will write it like this: 7 and 1.5 squared. Because 2.25 is 1.5 squared. Just to help us remember that the standard deviation is not 2.25, the standard deviation is 1.5. Okay? But here's what we're trying to find. It says the probability that this random variable x is below k is 0.63. So what is k? Well, let's look at what the question's asking here. It says that our mean is 7, so I'm going to put that right there in the middle of my normal distribution. And it says that the area is 0.63. Now, I'm looking at the area that x is below this certain value. Okay? So it's going to be area to the left of k on my graph. Since the area is 0.63, what do I know about where k is?
It's past the mean.
All right, the mean is what percent? 50%. 50%. So to be at 63%, I've got to be over here somewhere. There's k, and the area that they gave me, that 0.63, is all the area to the left of k.
How do we know that it's less? Is it going over there?
I'm sorry, what do you?
How do we know that it's on that side?
X is less than the k. Yes?
Is the 1.5 mean or variance? Mean?
The mean is 7. The 1.5 is the standard deviation. 1.5 squared is the variance. Okay? So, here's where we're going to use a new function on our calculator. All right? K is going to equal the inverse norm. Inverse norm. And when we do this, you always have to use the area below the value that you want. So 0.63. And then you also have to input the mean and standard deviation. So 7 and 1.5.
Where do you find the inverse norm? It's under...
It's actually, if you go right back where you found your normal CDF, it's the next function down. You go to second distributions, number 3, I believe.
So area
is 0.63.
Mm-hmm.
Mu is 7, and standard deviation is 1.5. But I don't, like, later, will we be able to do that without our calculator because it's basically an integral? Or it's supposed to be?
Well, I mean, theoretically, if you took the calculus and got really good at integrating and went on, then it's possible, but it would not be fun.
I thought an integral is the area under the curve.
It is.
So what's that?
Your calculator is doing an integral to give you, it's actually kind of doing the opposite of an integral in order to find what k is. Okay.
And when I plugged all this in, I got 7.497, whatever.
Okay, you got 7.497.
Yeah, but
So you would do 7.497. If you round to 2 decimals for IB, you would round that to 7.50.
but I don't understand what like k isn't a percentage. It's just a number on the x-axis.
Exactly, it's a score. Just like our mean 7 is a score, k is a score, 7.50.
And it doesn't have to be like a standard deviation away.
No, that's the thing. It can be any distance away.
So this is literally just plugging things into our
Yes. Now, let me show you kind of what is happening here. We had 0.63 for our area, okay? If we did not have our calculator, we would have to use this, okay? And we'd have to come over here and find 0.63. And the closest thing we've got, here's a 0.6293 and a 0.6331, so this is a little closer. So the best we could say is that z, notice this is the standard normal table, this is z equal to 0.33. Okay?
Why?
Well, because that's where 0.63, where the area under the curve was 0.63, right?
Yeah.
So if we did not have this function on our calculator, this is how we would have to do it.
So that just means that it's 0.33% of a standard deviation.
No. Yes, above the mean. It's 0.33 of a standard deviation above the mean. So what we would do...
Because I see can you go back? How'd you get 3.3? Because you pulled it from the 3.
Because it's in, there's the 3/10ths and
so
3/100ths. Huh?
You'd get pretty close if you use that.
You could, and people have used it a lot. And basically what you would have to do is you'd have to say, okay, I know the z-score is a 0.33. That's going to be whatever my actual score is minus the mean divided by the standard deviation, and you'd have to solve it, and you'd get pretty close to 7.5.
Well, if you multiply
7.495? Okay.
Because if you multiply 1.5 to the standard deviation by 0.33, you get 0.495, which you would add to 7.
Yeah, it's essentially the same thing.
How come you have to use that equation if you, every time you take something from the table of normal distribution values, you have to use that x minus mu over standard deviation?
Yeah, I mean, that's the definition of what z is. So, but the nice thing is for us, we don't have to do that.
Okay.
That's what we would have to do if we didn't have our inverse norm function. Okay?
On the test, is there no calculator section, or is like the whole point of the test?
There's not a no calculator section. There's one problem where I want you to use the I tell you not to use your calculator because it actually makes the whole problem a lot easier. Just think in terms of the 68, 95, and 99.5. That's the only reason I tell you don't use your calculator here, because actually it makes it a whole lot easier. But everything else you use your calculator for and you're fine. Let's take a quick look at another one, all right? Here it says, in the standard normal distribution, so that means my mean is?
Yeah.
0.
I wasn't wrong.
And my standard deviation is? 1. Okay, so this is 0. What z-score lies above 38% of the data?
So go a little bit to the left.
To the left? Okay, why are you saying to the left?
That's 50%.
All right, this is 50.
And now shade all the stuff to the right of that one.
Okay, so we want the score that's above 38% of the data. So there's 38%, 0.38.
I thought we wanted to score above that, so when you shade the other half?
Well, no, we don't want, we want the score, K, is above this 38%.
Let's score the exact, so we only get 1.
Yeah, yeah. We're getting one value here.
Can you go back out to the other one? Like,
It's the same thing. What is K? If K is greater than X, and that's 63% of the time. K is bigger than 63% of the data here. Here, K is bigger than 38% of the data. It's just a different way of saying the same thing. Yes. On these, we're always going to get a single answer.
That's all you have to do, right? And then
All right.
put in your calculator.
Now we're putting it into our calculators, okay? So, inverse norm, K equals the inverse norm of the area is 0.38, mean is,
0.
standard deviation is, and what do we get?
I had negative 0.305.
Is that okay?
yeah, because it's on the left side of that.
Exactly, yeah. We're to the left of 0, so it makes sense, so we should get a negative value.
Should we round that to negative 0.31? Or does it matter?
Yeah, we can go 2 decimals for IB as usual, round it to the 0.31, negative 0.31. Okay.
So that's all you have to do.
That's all you got to do with this. Now, there are a couple of ways that, or other things that we can try to find that just add one extra element of thought that we have to factor in. Here's one example. Okay. In the standard normal distribution, what value of z would show us where the top 35% would start?
So you just find 35% on
Where is the 35% going to be in this case?
the right side.
It's going to be on the right side, okay? So look, here is the K we're looking for. The 35% is going to be here. So question, what are we going to put into our inverse norm?
65.
There we go. The inverse norm always requires us to include the area below the curve. That's 0.65. Okay? Now, you don't have to do any other figuring once you figure that out. K is just going to be that number. It's going to be the same number that's above 65% that's below 35%. Okay? So, again, we'll use our inverse norm with a 0.65 below. We're in the standard normal distribution, so we have 0 and 1 again. And what would we get? .38. Okay, does that make sense?
Yeah, because it's standard.
Okay, yeah, it's standard normal. We're above, we're past the 50% mark. Okay, so we're going to be above the mean of 0, so that's why we're in the positives. Okay, so that makes sense. All right. All right. The last one I want to look at, again, just adds one extra element that we have to think our way through. It says the mean of a set of data that is distributed normally is 76.5. Okay, so there's our mean. The standard deviation is 5. But here, it says 45% of the data lies between 70 and what other value? In other words, the probability that our random variable x is between 70 and k is going to equal 0.45. So let's think this through. If I draw it, 70's right here, and k is going to be somewhere over here. Now, as it turns out, this one's going to be somewhat close to the mean, so I'm not 100% sure it's to the right. And I could adjust my drawing later if I needed to, if it turns out that our other score is under 76.5. But let's think about what our inverse norm, takes as arguments and what it gives us, and how would we approach this?
I think
Let's think this through. K is the inverse norm. And what goes in here?
We don't know the area. What will we do? So
What?
we know the area?
What's the area?
0.45.
Is that our area?
we need to figure out, we need to figure out what the area below 70 is, and then we need to add the 0.45 to it, and then we'll set that equal to it.
Okay, look. We were given this area right here is 0.45. Let's try that again. Okay, 0.45. That's not what the inverse norm takes. Okay? We do need to figure out what this area below is, and then we can use the inverse norm to find k. Alright, so how would I figure out what the area below 70 is? Well, the area below 76.5 is 0.5. But what about 70? How do we find that? This is Thursday and Friday. Actually, this is most of last week. What are we using?
Normal P?
Normal CDF.
Yeah, because P.
Okay? Normal CDF. I'm going to find what goes below 70. Alright? So I need a lower bound. Will 0 do it here?
No, yes.
Yeah, I mean our standard deviation is 5. That's 14 standard deviations below.
No.
That should be sufficient. Okay, so we could go from 0 to 70. And then we plug in our mean of 76.5 and the standard deviation of 5. And what do we get for that area?
0.096.
0.096. Okay, so now I know this is 0.096. So what am I plugging in? Hang on, actually before I even ask that, does everyone understand what we've done here?
Yep.
Okay. So now, what can we plug in?
Add up the two areas.
Good, we're going to add up these two areas. That'll give us our total area below K.
0.546 is the total area.
Okay, good. And then we know our standard deviation, or mean is 76.5. Standard deviation is 5. And that gives us K equal to
78.4266.
okay, 78.43.
I had different answer. Not 77.0.
That's what I do.
Did you use 0.546?
Yeah.
That's what I got.
Oh wait, yeah, I should have found what I didn't find.
Okay. What was it again?
77.07.
0.7 what?
0.07.
Oh, 0.077, so let's make it 0.08. Okay. All right. Any questions about any of these steps here? Okay. How to use this? Kind of as a review for the normal distribution, these are the three main calculator functions that we've used. Normal PDF is used only for graphing. You do not need to use this, okay? We use this only to illustrate the area under the curve using the integral on the calculator. The two you're going to use are the normal CDF and the inverse norm. And basically they do opposite things. Normal CDF takes a range of values, a mean and a standard deviation, and returns a probability. The inverse norm takes the probability with the mean and standard deviation and returns the K value, the value that that area is below. Okay? All right. So, any questions at all? All right, I'm going to stop.